بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will talk about numerical sequences. Specifically, we will see what is the meaning of a bounded sequence. Let n be a natural number. A sequence un is said to be bounded from above if there exists a real number k such that un is less than or equal to k for every n belongs to n. And a sequence un is said to be bounded from below if there exists a real number m such that m is less than or equal to un for every n belongs to n, or un is greater than or equal to m. So it will be bounded from above if it's less than or equal a constant, and it will be bounded from below if it's greater than or equal to a constant. And a sequence un is said to be bounded if it is bounded from above and from below at the same time. In other words, if un is bounded between m and k for every natural number n. Let's see an example. Un is a sequence defined as follows. For every n in n, we need to verify that un is bounded by 0 and 5. Let's see. We have 5n plus 1 is positive, and n plus 1 is also positive because n is a natural number. So we can say that the ratio is positive and un is greater than 0. So till now, we proved the first part of the double inequality. Well, for the second part, if we find un minus 5, we get 5n plus 1 over n plus 1 minus 5. If we simplify, we get negative 4 over n plus 1, and we know that negative 4 is negative and n plus 1 is positive because n is a natural number, so the whole quotient is negative. Consequently, un minus 5 is less than 0 and un is less than 5. Therefore, un is between 0 and 5. Let's see this application. Un is a sequence defined as follows. First part, we need to prove this identity. Try to do it alone. So by expansion, we get the answer. We need to prove by mathematical induction that un is bounded between 0 and 1 plus radical 5 over 2 for every n. Try to do it alone. Let's begin proving by mathematical induction. Remember, we always put the question. We need to prove that un is bounded between 0 and 1 plus radical 5 over 2. We verify it for an initial term for n equals 0. So is u0 bounded between these two quantities? We know that u0 is 0 from the given, and 0 is bounded between 0 and this quantity, so this is true. We suppose that the statement is true for n equals k. Remember, this is the statement that we are proving. So we know that uk is bounded between 0 and 1 plus radical 5 over 2. And we prove the statement is true for n equals k plus 1, or we need to prove that uk plus 1 is bounded between 0 and 1 plus radical 5 over 2. Well, if we begin by the supposition, uk is between 0 and this quantity. If we add 1, we get uk plus 1 is between 1 and that quantity. If we simplify, we get this answer, and then if we apply a radical, we get this quantity. And remember that 3 plus radical 5 over 2 is 1 plus radical 5 over 2 quantity squared, so its square root would be 1 plus radical 5 over 2. And from here, we can say that uk plus 1 is the square root of uk plus 1 is bounded between 0 and 1 plus radical 5 over 2. Therefore, un is between 0 and 1 plus radical 5 over 2. Now remember, dear students, here, If this radical is between 1 and 1 plus radical 5 over 2, it will be automatically between 0 and 1 plus radical 5 over 2. Let's continue. Property 1. An increasing sequence that is bounded from above is convergent, and a decreasing sequence that is bounded from below is also convergent. These are called the theorems of monotonic sequences. So increasing and bounded from above will converge, and decreasing and bounded from below will also converge. Un is a sequence defined as follows. The question is to prove by mathematical induction that Un is bounded between -1 and 0. So by recurrence, the question is to prove that Un is between -1 and 0 for every n. We begin verifying the statement for n equals 0. Is U0 between -1 and 0? This is correct from the given. So this is true. We suppose that the statement is correct for n equals k as usual, and we prove it for n equals k plus 1. We need to prove that uk plus 1 is between -1 and 0. We begin uk by supposition is between -1 and 0. So uk plus 1 is between 0 and 1 by adding 1 to all sides. Again, uk is between -1 and 0 from the supposition. If we multiply it by a minus, we flip the boundaries, we get minus uk is between 0 and 1. Now we can multiply both inequalities. We can say that minus uk into uk plus 1 is between 0 times 0, which is 0, and 1 by 1 is 1. But this is not what we need. We need it without this minus, so we go back multiplying by a minus and flipping the boundaries. We get this quantity is between -1 and 0. Remember, this quantity is the same as that one by replacing n by k, so we get uk plus 1 is between -1 and 0. This is true. Therefore, un is between -1 and 0. So far, we know that un is bounded from above by 0 and bounded from below by -1. Prove without using mathematical induction that un is an increasing sequence. Well, to be an increasing sequence, we can find un plus 1 minus un and we compare it to 0. And in fact, un plus 1 minus un is nothing but un quantity squared, which is positive, greater than or equal to 0. So we can say that un is increasing. So let's continue. Deduce that the sequence un is convergent. Well, to be convergent, it could be increasing and bounded from above or decreasing and bounded from below. In this case, un is increasing, so we use that un is bounded from above by 0. So I come and say that un is a convergent sequence being an increasing sequence that is bounded from above by 0. Remember, you have to specify the boundary of the sequence. I mean, if you say that it's bounded from above, it's not enough to state the statement, but you have to state that it's bounded from above by a certain number, which is specifically in this case, the 0. Okay, so these are the theorems of monotonic sequences. Remember them. Un is a sequence defined as follows. We need to prove by mathematical induction that the sequence is bounded from below by 0. Remember what we mean by a sequence which is bounded from below. It means that this sequence is greater than or equal to a certain constant, and in this case the constant is 0. Try to do it alone. Let's see. So the question is to prove that un is greater than or equal to 0, because in this case, if we prove this quantity, we can tell that it's bounded from below by 0 for every n. Let's do it by induction, as the question stated before. We verify the statement for n equals 0. So is u0 greater than or equal to 0? In fact, u0 is half, so the statement is true. We suppose that it works for n equals k, so we do know that uk is greater than or equal to 0, and we prove that the statement is true for n equals k plus 1. In other words, we need to prove that uk plus 1 is greater than or equal to 0. If we go back to the definition, now the question would be, is 2uk plus 1 greater than or equal to 0? Or is 2uk greater than or equal to -1, or is uk greater than or equal to -half? We know that uk is greater than or equal to 0, so it will be automatically or directly greater than -half. So this statement is true, and consequently we can say that un is greater than or equal to 0. So by now we know that the sequence un is bounded from below by 0. We need to prove that the sequence un is increasing. Try to do it alone also. Well, here if we find un plus 1 minus un, it will be un plus 1, and this is always positive because we know from the previous part that un is positive. So un is positive and plus 1 is positive, so the whole quantity would be positive. The difference is greater than or equal to 0, means that un is an increasing sequence. So by now I know that this sequence is increasing and it's bounded from below. The question is, can we deduce that the sequence un is convergent? Try to answer it. Well, we cannot tell whether un is convergent or not, though un is increasing, but we don't know whether it's bounded from above or not. So remember, if it is increasing, we need to check up whether it's bounded from above or not. And if it were decreasing, we need to check up whether it's bounded from below or not. In fact, unfortunately here, we know that it's bounded from below and increasing, so we cannot tell whether it's convergent or not. We need more information. Thank you.